Hi there, and welcome to another lecture of CSE331. This is WRA, and today we're going to have an informal introduction to finite automata. Now, what is a finite automaton? And by the way, automaton is the singular form of automata. A finite automaton is a mathematical model. The good thing is, you're quite familiar with this kind of models already. You can think of it as graphs that we've studied in algorithms, or we can represent it as a table. A finite automaton can store a finite amount of information, as the name may suggest. Which sounds like a limitation, and you may think that in most cases, the amount of past information that we need to remember or store is unlimited. And you're right. This model won't work in those cases. But this finiteness of the model does have its own benefits when it can be used. For example, you can tell whether two automata are equivalent, meaning whether they do the same thing or not, or if we can find a smaller automaton that does the same thing and make it more efficient. For a normal code, however, these things aren't so methodical. A finite automaton is made up of a finite number of states. Each state has a name, and ideally, that name should represent what that state remembers or what it means to be in that state. The automaton moves from one state to another in response to an input sequence. Inputs can be a sequence of characters if we are processing something like a text, or it can be a sequence of events. The rules that tell you how the state changes, how the automaton moves from one state to another in response to its inputs, are called transitions. You may recall seeing this block diagram in one of the previous lectures, where there's a finite automaton, and given a sequence of inputs, it can tell you whether that specific input sequence is accepted or rejected by the finite automaton. To see how we can design a basic finite automaton, let's take an example of a buzzer quiz, where the rules go something like this. So there will be two teams, Team A and Team B. Both are asked the same question each round. Whoever presses the buzzer first gets to answer. The team gets a point if the answer is correct, but for wrong answer, the other team will not get a chance like they do in a typical buzzer quiz, but because we just want to keep things simple for now. We wouldn't want to complicate things. And whichever team reaches 8 points, they will win. Now, let's see how we can construct the automaton for scoring the quiz. It starts at state 00, which represents a history when the quiz hasn't started. We indicate that this is the starting point with the arrow and the label start. Before the game starts, the score is 0 for both teams, as the name of the state shows. On left, we have Team A score, and on right, we have Team B score. After the first question in the quiz, either A or B may score a point, or maybe they get the answer wrong, and none of the teams get a point. We need transitions for all of these cases. If A scores a point, we move to state 20, meaning A's new score is 2, and Team B's score is unchanged from the previous state, which was 0. The transition is shown with an arrow labeled as A. If B scores a point, we follow the transition labeled B and move to state 02, which means Team B has a score of 2 now, and Team A is still at 0. And by the way, they get 2 instead of 1 because I assumed that in this particular quiz, 1 point means a score of 2. Now the third case. It's not necessary that the team that presses the buzzer first will in fact get the answer right. In that case, none of the teams get a point and the score remains the same for both teams. So the automaton should stay in the same state. And that can happen in every single state, at any point in the game. That's why we have a transition that's labeled N that loops back to state 00, which represents that none of the teams could score a point and the automaton stays in the same state. From states 20 and 02, the automaton can move to 3 new states. From 20, if A scores a point, we go to 40, and if B gets a point, it goes to 22. From 02, if A gets a point, the score is 22, and if B gets it, the score is 04. It's interesting to see how the state 22 doesn't hold an information as to how it got there. It can be one of the two cases. A got the first point and B got the second one, or maybe B got the first one and A got the second one. And we don't really need that information. We don't need the automaton to remember it because it has no effect on the final outcome. It only stores the information that is useful. From here we can get to 4 new states considering one of the two teams scores a point, and let's not forget the case where none of them does. If we're at state 60 and team A gets the next point, team A's new score will be 6 plus 2, which is 8. And according to the rule of the game, if a team gets 8 points, they win. So in that case, team A wins. And for state 06, the same thing happens for team B. We draw the other transitions from the remaining states, and by that I mean 4, 2, 2, 4, and 2, 4. We do it just like before. I would encourage you to pause the video at this point and try to complete it by yourself. Now, moving on, let's look at the states 6, 4 and 4, 6, which can lead to a score of 6, 6. Similar to how we got to the state 2, 2 from 2, 0 and 0, 2. From the state 6, 6, if team A scores the next point, they win. And if team B scores the next point, team B wins. Notice how we stay at score 6, 6 until one of the teams scores a point and reaches a score of 8. It's important that you understand that idea. To see how this automaton works, let's try and process an input string. Now this is the input string, and it's made up of the symbols A, B, and N. A, B, and N are the events of A getting the point, B getting the point, and no one getting a point respectively. But we're representing the events as a sequence of characters to theorize the whole thing. Now, before the quiz begins, the state we're currently in is the start state labeled 00. The first character in the input is A, which is shown by this arrow. This means that A got the first question. So the automaton should move to 20 as indicated by the transition labeled A. So team A's current score is 2 and team B's current score is 0 as indicated by the state 20. The next input is B. which means Team B got the next point and the current state is 2, 0. So we follow the transition on B from state 2, 0, and we go to state 2, 2. The next two inputs are N, that means no one could get a point, and the scores remain the same for both teams. So we stay in the same state, which is 2, 2. As you can see, the transition labeled N is a loop on the same state. It will stay in the same state as long as no team scores a point. Make the questions hard enough with no time limit, we could be stuck here forever. But thankfully, the question wasn't that hard. And according to the next input, B got the answer. So from 2, 2, following the transition on B, we go to 2, 4. The team A scores the next point, so from 2, 4, we follow the transition on A and reach the state 4, 4. We see another N and the current state stays the same. After that, B scores a point and we move to 4, 6. According to this input sequence, the last 2 points are scored by Team A. So when we're at the state 4, 6, after A gets a point, we move to the state 6, 6. And the last point is also scored by A, so from 6, 6, A's score would now be 8, which means Team A wins the game. If you're rooting for Team B, I'm sorry. Hope that gives you a general idea of how a finite automaton works. That's it for today's video, and I'll see you in the next video.